Okay, so let's look at another example. So the first example in 3, we're looking at the limit. Underneath that limit, LIM is an x, an arrow, a -2 raised to a negative power of f of x. So because it has that negative on top of that 2, a -2, it's telling me that I'm looking at this coming in on the left-hand side. And so I would first denote where my -2 is on the graph. And I'm looking on the left, so I take the piece that is on the left of x equals -2, which is here, and I follow that graph as we get closer and closer to that x value and try to determine what is that y value that we're getting closer and closer to. So I notice that as I get closer and closer to this x equals -2, I'm getting closer and closer to this y equals 1. And so the limit here is equal to 1. So B says, let's look at the limit as x approaches -2, but this time on the right-hand side. And so because there's a jump in that graph at x equals -2, that piece is coming in, this right piece. So looking at that, coming in on the right, following that graph, coming in on the right as x is going to -2, notice that my y value down here is getting closer and closer to -2, but not ever going to hit it because it's an open circle. But the limit is equal to, right hand side limit is equal to -2. But that left hand limit and that right hand limit gave us 2 separate y values. And so when you see the limit and doesn't have showing us that we're looking at either the left or the right hand side, there's no negative or positive exponent piece on that -2 under there. It has to go to the same number, and those are not the same number. And so we would say for part C, the limit as x approaches -2 of f of x does not exist. So I'm just going to put D and E there. Excuse me. For does not exist. So D, we're looking at the limit as x is approaching 1. I don't see any of those, that superscript of plus or a negative sign. So I know I'm looking at both the left and the right hand side, and we're seeing what it's equal to. So let me erase this real quick if I can. And so let's denote where x equals 1 is on that graph. So located x equals 1 here. And I need to make sure that the left-hand side and the right-hand side are coming to the same value. So if we're coming in on the left-hand side of x equals 2, notice even though there's an open circle there, that y value is still getting closer and closer to 1. So maybe I'm getting 0.9, 0.999, 0.99999. And so I'm getting closer to when x is going to 1, a y value form. Same thing on the right-hand side when I'm following this down. Even though there's an open circle, it's not defined at that point, it's down here. That y value is still getting closer and closer to 1. And so the limit does exist, and it is equal to 1. So same idea for E. Now we're looking at the limit as x is approaching 0. But notice there's no positive or negative superscript there on the 0. So we have to see that left and right are coming in are the same number, y value. So on the left of 0 following the graph, on the right of 0 following the graph, notice that you're coming into the same y value, and that same y value there is -2. So part F, we're looking at the limit as x is approaching 3, but that negative superscript is saying that I'm looking at 3 on the left. Let me erase this and then we'll locate 3 on the graph. X equals 3 on the graph. And looking at the left. So just on the left-hand side, is it coming to one y value as we get closer and closer? And we are coming to one y value, and we're coming closer and closer to a y value of 5. So limit as x is approaching -1. So we have to look, is the left and right the same when x is -1? And it looks like it. There's no jump in there, right? We're coming to the same y value. And that y value that we're getting closer and closer as the x is approaching -1, both on the left and the right, gives us a y value of 3, -3. So for h, we're looking at the limit as x is approaching -3. So if we look at x equals -3, I notice there's no jump there in that piece of the graph. And that y value that we're coming to is y value of 0. Okay, so I and j are not taking limits. Those are asking us what are those points. So this is saying when x is -2, so f of -2, when x is -2, what is your y value? So when x is -2, notice that's where the jump of the graph is. One of them has a solid circle and one of them is an open circle. So it's a solid circle where it's defined. And so when x is -2, the y value is actually 1. So same idea with f of 1. This is asking, what is that point when x is 1? What is your y value? So if we locate when x is 1, notice that the graph, there's an open circle with a piece that we would be following when we're graphing it, but below that open circle is a closed circle. So that closed circle is actually the point on the graph. And that point would be, the y value is -2. Okay, so a good example kind of showing you the difference with the notation of left or right limit, or if you're just looking at the limit in general. So when does the limit not exist? So there's actually multiple places where a limit would not exist. One of the things that we said is the left-hand side and the right-hand side have to go to the same number. So when does a limit not exist? One way would be saying the limit as x approaches, let's say c on the left, with that negative superscript of f of x, does not equal the limit as x approaches c from the right of f of x. Okay, so we'll also see that limits don't exist if they are shooting off to positive or negative infinity. We just haven't looked at that yet. So I'm going to come back to that later. But right now we know that it doesn't exist if the left and the right aren't the same.